Hello again. This is the second part of the rational expressions. I'm going to do a couple examples. There's a couple on the last page of the notes that are kind of tricky. I got one in these notes I might do. The other ones aren't going to take too long. But let's just get started and we'll see how far we get. So this one is honestly, in my opinion, about as hard as any of them because you have four little fractions and one big fraction, and the denominators of these fractions are not factored yet, so you're going to have to do that first and then see what the common factors are, which is like not that bad, but it can be a little confusing. So I can see that there's a 2 common to both of these, 2x minus 1. And then this one has no common factors. X and 1 have no common factors, so that's factored. The same is true of this first one on the bottom. X and 1 have no factors, so that's that. And then this now can be factored as x plus 1 and x minus 1. That is a difference of squares. And we've seen that before. Hopefully you remember it. And now if you want to build a common denominator, we got to think about the factors of each one of these denominators. So this has a 2 and an x minus 1 in it, which means both of those must be factors of the LCD. This has an x plus 1 in it, which I don't have here yet, so I got to add that. It's always how I build them. I just start with 1. I need both of the factors now, then I keep going through the things and see if I have what I need. So if I do the 2, the x minus 1, I needed the x plus 1. And now for this bottom one, the only factor of this is x minus 1, but I've already got one of those, so I don't need to add another one. And here I have an x plus 1 and an x minus 1, and I can see that both of those are already in this one. So this is my LCD, so to speak. And what we said before is we end up just multiplying the top and bottom. Oop, I wrote it in the wrong order. Okay, let's start that. Let's try that again. We multiply it, the top and bottom, numerator and denominator of our complex fraction by this LCD, and we see what happens. So this times the numerator here, this 2 and that 2 will cancel out. This x minus 1 and that x minus 1 will cancel out. The x plus 1 will be left, as will the 3. That didn't get crossed off by anything, so I have 3 times x plus 1. Here I have x plus 2. The only, start that over. The only factor down here is x plus 1. And there's one of those here, so those will cross off. I'll be left with 2 times x minus 1 times 1. Don't forget that was minus. I did not write the times 1 because we know that anything times 1 is just itself. Now my only factor down here is x minus 1, so this will cancel out with this. And I'll be left with 1 times 2 times x plus 1. And now I have x plus 1 and x plus 1, those will cross off. X minus 1 and x minus 1, those will cross off. The only thing left here is 2, and the only thing left here is x, so it's plus 2x. And then you ought to combine the like terms here. This is 3, I'll write it out, 3x plus 3 minus 2x plus 2 over 2x plus 2 plus 2x. You notice I did negative 2 times x and got negative 2x. And I was careful and did negative 2 times negative 1 and got plus 2. Now I just combine all my terms. 3x minus 2x is x. 3 plus 2 is 5. And 4x plus 2 on the bottom. This could be factored, but it's not going to change anything. It's not going to make anything, I'm not going to cross anything out by doing that. So this is as good as any answer right here, in my opinion. So we can leave it like that if you'd like. So like I said, that one was a little bit more of a pain because you had to factor these denominators first, and then the LCD of all the fractions was like a little funky. But other than that, this problem is not vastly different from one you might see anywhere else. This one I feel like is a bit easier. I think I included it to remind you of this one single fact that 4m, which is the top of this fraction, is, of course, itself a fraction. It is 4m over 1. So now I can look at the denominators of these three small fractions, which live within my big fraction, and see that the LCD of 1m and 3 is equal to 3m. So I multiply the top by 3m and the bottom by 3m. This, nothing cancels out because it's 3m and 1, and those have no common factors. So the top is 12m squared, 3m times 4m. You can remember those are over 1. I think that helps you guys sometimes to write that. 3m over 1 times 16 over m. This m will cancel out with that m. I'll be left with 16 times 3, which is 48. And then 3m and 3, the 3's will cancel out, and I'll be left with 16m. You can see there's a 4 in each one of these terms. I could cross that out. And that's it. That, my friends, is all she wrote for that one. Easy peasy. And I'll do this last one here, and then I'll maybe tackle the last page in a different video. Like I said, those are a little harder. I would like this to go away. There it is. So I wrote picking the correct strategy, which means like not the adding them together and then dividing, but the multiplying by the LCD trick. This one is much, this one's like, you would never add these together and then divide them. You would always use the LCD trick, which is like multiplied by A over A. The denominators of the A and the 3 and the A and the 6, those are all 1, so they don't really come into play when calculating the LCD. So that means the LCD just has to be A. So what happens when you multiply all this stuff together, A times A is A squared, A times 3 is 3A, and A times 2 over A is just 2. A squared plus 3A plus 2. And then I do something similar here, A squared plus 6A plus 5. So this is no longer a complex fraction. It's not simplified all the way. So it might be, you just don't know. You got to factor the top and bottom to see if it is. I'm pretty sure that this can be A squared plus 6A. So it looks like the A plus 1s are going to cancel out. A squared plus 3A plus 2. A squared. Okay, so that's good. Yeah. So you can see that these kind of come in a bunch of different flavors. These ones where there's just like these monomials in the bottom, and you just got to find the LCD like we did over here. These ones where there's like, sometimes there's terms, these are binomials on the bottom, and you got to factor each one. This one was another one with monomials in the bottom, and there was a reminder that 4m is really a fraction like 4m over 1. And this one where the only thing that had a denominator were the a's, and at the end we had to factor and cross things out. Just so you know, the questions that involve these will say something like simplify completely. And when I say that, I mean like all the factoring done, all the canceling done. So we'll talk more about that when we get closer to the assessment. So y'all keep an eye out for slide 4 in the next video.